In this unit, we're going to focus on solving equations. In this lesson, we're going to be solving inequalities.
All right. Hi, everybody. So in this lesson here, we're going to be solving inequalities as opposed to the equations that we were solving before. Okay. And so what we mean by inequalities here is we're going to be using the less than or equal to, greater than or equal to, less than, greater than symbols, okay, instead of the equal sign. So like it says right here, here's an equation with an equal sign here, here's an inequality. Okay. Now it turns out the way we manipulate these things are very, very similar. Okay, we're going to still move objects from one side of the equation or the inequation to the other, just like we did with an equation here. Now, just in case you're having a little bit of difficulty remembering which one is which here, just remember how this works here. With an equal sign, the reason why this is an equal sign is because the distance between the two ends is the same on both sides. Same on both sides here. However, if we pinch one side together here, the distance here is smaller. In fact, it's like 0. But over here, the distance between those two ends is much greater. And so, and because we read these things, we always read them. Okay, they are read left to right. This means the larger side here is on the left here. So the left side is larger or greater than the right. And that's how you are supposed to interpret that. And the other way around here, clearly then this symbol right here would be less than. Okay, because the larger amount is on the right-hand side here because the distance is further apart here. Now, you may have memorized that dealing with alligators, where the alligator is eating the larger amount, or Pac-Man is eating the larger amount, kind of whatever here. Just as long as you got some way of memorizing that, making that clear in your head here. Now, one of the things that we're going to do here is typically we're going to write the expression with the variable on the left because it makes more sense. So just to go through and illustrate what I mean here, if we take a look at this first one here, this one says that x is less than, because it's pinched on the side of the x, it's less than 10. Okay, now we could, however, have done it like this. We could have written it where 10 and have it written like that, where we would say here 10 is greater than x. And that says exactly the same thing. Okay, they're identical to each other. All I've done is kind of flip the whole expression around, but the relationship it's stating is the same here. It's just that this right here is a little bit harder to process. Okay, putting the variable at the end, it's much easier for us to just kind of process, oh, x is less than 10. X is going to be values that are smaller than 10 here, as opposed to saying that 10 is greater than. So starting with the 10 and then figuring which direction to go. But it doesn't really matter. So this one here, n is greater than 50, okay? And then when we add the little symbol underneath, that is just adding that or equal to, okay? So it's including the endpoint. So up here in these two right here, we would not include 10. I would, if I was asking what are the values of x where x is less than 10, I would not include 10 in that. Okay, 10 would not be part of that. Just like, what are the numbers that are greater than 50? Well, I would not include 50 in that. But if you had the or equal to here, yes, I would. Now, one extra little thing before we get into some questions here is when you're solving an inequality here, we use the same techniques as solving equations, but there is one additional rule here, that anytime you multiply or divide by a negative number, it flips the direction of the inequality. Okay, so anytime you do that, greater than becomes less than, or less than becomes greater than. And it's only with multiplication or division. It is not with addition or subtraction. So you got to keep that separate in your head here. So let's take a look at some examples. So this first question, negative 2x plus 7 is less than 19. So first thing we're going to do here, again, we approach this exactly as if that was an equality there. So I'm going to subtract 7 from both sides so that I've got a single term on the left with an x in it. That gets me negative 2x is less than 12. And now to get the x by itself, I'm going to divide by negative 2. Now, we were talking about this just a moment ago. When we divide by a negative, that is when the sign changes direction. So instead of being less than, it'll now become greater than. And 12 divided by negative 2 is going to be negative 6. Okay. This next one over here, 4x minus 7 is greater than or equal to negative 15. So just like we did before here, the first thing we're going to do is we're going to add 7 to both sides. Now, that does not change the direction of the sign. Okay? It's going to give you negative 8 on the right-hand side. And it doesn't matter that that's a negative 8 on the right-hand side. The operation there was just addition. And now I'm going to divide by 4. And that's okay because it's positive 4. So this is going to be x is greater than or equal to, and it doesn't matter that the right-hand side becomes a negative value. I did not divide by a negative. Now, check this one though. This one right here, I don't even have to bring over a constant. Okay, this one is simplified in that respect. It's just the term with the variable in it, but I'm going to divide by negative 1/2. I'm going to divide both sides by negative 1/2. That does mean I'm going to change the direction of the sign. And 5 divided by negative 1/2 is going to be the same as 5 multiplied by negative 2 over 1, or negative 10. So x is going to be less than negative 10. And for this last one right here, just like I would have done if this was an equality here, I am going to multiply through that 4 first, less than or equal to x minus 15. And then what I'm going to do is I'm going to bring the x's to the same side here. So I'm going to subtract the 1x here, I'm going to subtract that x here, so I'm going to get 3x minus 4 is less than or equal to negative 15. Now, to get the term with the x by itself, I'm going to add 4 to both sides. So this will get me 3x is less than or equal to negative 11. And then I will divide both sides by 3 to get that x is less than or equal to negative 11 thirds. And I really can't simplify that any further. Okay, so now you really should take a couple moments here, try these couple questions, see what you can make of them. And then, pause the video, maybe take a moment. I'm just going to plow ahead here. So I'm going to subtract 1 from both sides to get negative 2. X is less than negative 1. Now, bear in mind that subtracting, or that negative 1 there, because it's just addition subtraction, it does not change the direction of the inequality sign. It stays less than. But now, because I'm going to divide by negative 2, that is what changes the direction of the inequality symbol. And so now this becomes, that was by negative 2. So x is greater than positive 1/2. Now for this one right here, because I know that I'm going to be dividing by that coefficient of the x here, I'm actually going to convert that into an improper fraction first. So 1 times 3 is 3 plus 2 is 5. So it'll be 5 thirds. X minus 3 is less than 4. So to start with, I will add 3 to both sides. So 5 thirds x is less than 7. And then I'll divide by 5 thirds. Now I'm dividing by a positive, so it's not going to change the direction of the sign. And dividing by 5 thirds is the same as multiplying by 3/5. And so that becomes 21 over 5. And so we can write there that x is less than 21/5. Okay, now before we wrap this up here, one other thing that we want to mention here is that when you're solving inequalities, you can actually illustrate your answer on a coordinate grid or on a number line. We can draw a picture of this. Okay, so for example, we've got this x is less than negative 1. where x is an element of the real. So we could sketch it in this manner right here. Now, because I'm referring to x variable, this is going to be horizontal. Okay, the important information is going to be conveyed along the horizontal axis here. So first of all, notice that I'm relating x to the value -1. So now that is going to be right here on the x-axis. And so what I do is I'm going to draw a dotted line, a vertical dotted line, through that -1 here. Now, the reason why it's a vertical line here is because I'm identifying that line where every coordinate, x coordinate along that line is going to be -1. So that line shares all of the points share the same x coordinate. And now less than, when I say x is less than -1, on the coordinate plane here, x less than something always means to the left. So this is going to look like this. What I'm going to do is I'm going to shade to the left of that dotted line. That's what it would look like on the coordinate plane here. If I was to go to the number line, what I might do here is I'm going to put a circle around -1, and then I'm going to shade. I'm going to put like a shaded little arrow indicating which way I want to go. And so that tells me that I'm looking at the x coordinates to the left of -1. Now, another way that you might see this done is they'll put -1 here, put a circle around it, and then they'll put an arrow coming up and away and to the left. Okay, now, another question right here. And actually, in this case, I write here, I tell you what, just humor me a little bit. Let's change this a little bit. Instead of having this be greater than or equal to, let's make this less than or equal to. Okay, less than or equal to. And so now, when I try to solve that, first thing I'm going to do is I'm going to add 16 to both sides. So it's going to get me -12x is less than or equal to -24. Okay. And then I'm going to divide both sides here by -12, and that is going to change the direction of the sign. So it's going to become greater than or equal to, and then -24 divided by -12 is going to be +2. Now, in this case, to draw that or to illustrate that along the graph here, I'm going to put a solid vertical line on 2. And greater than or equal to means I'm going to shade to the right of that line. Okay, greater than, when we're talking about the x coordinates, greater than means to the right of. On the number line, I'm going to put a circle around the 2. I'm going to fill that in. And then I'm going to draw that arrow again to the right. Or you'll see them do something like this, where they'll put a 2 down there. They'll put a closed circle on the 2. And then that arrow kind of pops up and goes to the right there again. So, graphically speaking here, what is going on here? Well, when we've got less than or greater than, on the number line here, what we're going to have here is we're going to have an empty circle on that value. But if it's or equal to, this is going to be a filled in circle. On our coordinate plane here, that is going to be a dotted line. And if it's or equal to, it's going to be a solid line. But notice in both cases, we're talking about a vertical line here. So I think we're going to understand, or we're going to assume that people understand that when we say less than, we mean left. Okay, so less than is shade left. Greater than is shade right. Now that is consistent. That is consistent with the values and the direction along the x-axis there. Smaller numbers are the left, larger numbers are the right here. So really, what we really needed to point out here, was what happens here to illustrate whether or not that value is included with the group or not. Are we including that other number here? So when we say, for example, well, let's go up here again. Let's go up to this other one here. Like, are we including that too? How do we show graphically whether or not that 2? It's easy to show whether I'm talking about values greater than that 2 or less than the 2, because I can shade, I can draw that all in here. But the issue is whether or not you're including that 2. So the solid line or the solid circle means we're including the 2. The dotted line, empty circle, tells us that we're not.